Welcome again to our online viewers. We're going to carry on hearing about the remaining SOLARISE pilots. And these are looking at some different areas. We now have a session on the pilots in social housing and in historic buildings. And so we're tackling some of the most difficult issues to make sure that those buildings can maximise the benefits for occupants as well as cutting carbon emissions. This is one of the sort of very tricky areas. It's not like sort of creating a solar farm. You have so many regulatory and social issues to think about. So first, we're going to hear from Brighton and Hove City Council and about one of the pilots that we've been doing in public housing. So I'd like to introduce Jo Thompson, Regeneration Programme Manager, and Dan Walters, Technical Project Manager from the Regeneration team in Brighton and Hove City Council. Thank you. Jo.
Well, thank you for inviting me, and I'm delighted to be here to speak to you all today about our pioneering project, which is Victoria Road, our most sustainable scheme delivered under the New Homes for Neighbourhoods programme. Before I start the presentation, I'd just like to thank the City Council and the SOLARISE Interreg programme for agreeing to fund a significant proportion of our capital costs for the project, as well as the production of the video, which we're going to show at the end. Without that funding, we would have really struggled to deliver some of the really innovative features and sustainable features of the project. So thank you very much for your support. It's much appreciated. In 2018, Brighton and Hove City Council, along with many others, declared a climate and biodiversity emergency and made a commitment as a city to become carbon neutral by 2030. The way in which we act and the choices we make directly impact on the effects of climate change. And we know that reducing our carbon footprint can lead to lasting change. So what did we decide to do about this? Well, the council has been really proactive in this area. We've adopted a new build housing sustainability policy, and the policy writer is here with us in the audience today, Nick Fisherock, for new council housing supply. We're developing a bespoke design specification for carbon neutral homes within our programme. And we've agreed that renewable technologies and sustainable construction should be at the forefront of our house building programme. So in line with the Council's carbon neutral objectives, the Victoria Road housing project will be delivering the highest sustainability standards of any projects delivered under our New Homes for Neighbours programme. The programme delivers new council homes for people on the council's housing register who are in desperate need of housing. The Victoria Road project is currently under construction and is being developed on brownfield land on a former housing office site which is owned by the council. And through efficient use of the land and through managing the assets, we managed to bring forward, instead of just 15 units, 42 units of accommodation. And that was achieved by basically relocating a bowls club, which was located, I think, somewhere here. Sorry, I didn't know whether... Here's the bowls club itself, and there's the sports pavilion at the end of the housing office. And we relocated them to the park across the road. And that really necessitated, made the whole site available for bringing forward housing. The site's located next to Portslade Town Hall, and it's about 5 minutes away from Portslade Railway Station. Our vision was to create a vibrant, highly sustainable scheme designed to enhance the lives of those who live there. The scheme delivers for the long term, creating a new sense of place and pride in an area that has lacked investment for years and suffers pockets of deprivation. In fact, whilst we were under construction and before demolition took place, and I always like to recount this story, we had a homeless guy occupying the toilet block, which was literally an isolated block that supported the old town hall. We got our homeless team in proactively to try and find out and sort out some alternative accommodation. But those pockets of deprivation are there in Portslade, and also evidenced by a very active food bank which operates from Portslade Town Hall and has been doing so for the last 10 years. So Portslade is deprived in pockets, and we think this scheme will be addressing that directly. The scheme comprises of 2 blocks and is a mixture of 1, 2 and 3 bed apartments. The homes have been designed with really generous space standards and very highly energy efficient, and we'll talk about that a bit later on, reducing fuel bills for residents and combating fuel poverty, which we think is absolutely central in today's society where we have really high energy bills. And 10% of the homes are suitable for people with disabilities. I'm not going to speak any more about the scheme overview at this point. I'm going to pass over to Dan Waters. Dan is our technical project manager. We're delighted to have him on the team, and he's been overseeing the installation of our PV system jointly with our lead contractors, Morgan Sindall, and our electrical contractors who are here today as well, AJ Taylor. So thank you. I'll pass over to Dan.
Thank you, Joe, and yeah, I'm delighted to be here as well. So I'm going to try to take the technical kind of side to the project, if that's okay. So Victoria Road is, as I said, is a change to the traditional approach that Brighton and Hove City Council have previously designed and built, and it's got heavy kind of sustainable construction methods and renewable technology installed. We designed the scheme to have a large photovoltaic system, a ground source heat pump system consisting of individual heat pumps in residents' flats, fed from a low ambient temperature loop, living walls to help with shading, overheating and increased biodiversity net gain. And we've also got a provision for electric vehicle chargers on the site of a landscape designed for inclusiveness and well-being. So Victoria Road Housing Scheme solar PV system has been designed to produce 63,500 kilowatts of solar energy. It's expected to save 14 tonnes of CO2 annually, and the council are actively exploring if a private network can be set up to utilise the solar PV and the ground source heat pump systems to pursue a saving on residents' energy bills. And the PV system is designed to enable future-proofing to enable us to implement this private network. As I said, we have installed 168 solar PV panels, utilising all 3 roof spaces across the scheme, and the system is split into 3 systems. Block 1 North has 49 panels, consisting of 2 strings or circuits and 1 inverter. Block 1 South has 24 panels and 1 string with 1 inverter. And finally, Block 2 consists of 95 panels across 4 strings, utilising the primary and secondary inverter. And with the SOLARISE funding, we will be able to, we'll actually be able to maximise the amount of kind of solar PV that we can install. So we have selected specific inverters that works with optimizers, and this is preferred over a conventional system. So we could potentially achieve another saving between 2 to 30% or more energy. So each panel operates independently. So on a conventional system, if one panel was to have an issue, shading, dirt, or any kind of issues with it will create resistance. It normally affects the whole array. With this system, with an optimizer, it actually only affects one panel. It only affects one panel, so obviously not affecting the majority of the system. Power optimizers will also enable a full automatic shutdown for DC voltage whenever AC power is off or the inverter is disconnected, and this is really important. It ensures safe isolation when maintenance teams are either working on it or for any reason that people need to be able to shut it down in case of emergency for fire services or anybody else. So, SOLARISE funding has, as I said, has helped the council to deliver housing schemes that include and much more maximise PV on our roofs. We have a contribution to the capital installation at Victoria Road and to enable a feasibility study to be completed to renew possible private networks and include future possibilities. The council commissioned a report for a previous council development, and the study looked at increasing solar capacity on HRA assets and analysed different models for PV generation on council housing. And we picked a sub-metering model, and this was piloted at a scheme, Buckley Close. Unfortunately, it was not eligible for solar funding, but the project informed Victoria Road in terms of our future plans for that private network. So it's valuable information. As I said, so the council completed the feasibility study as part of Victoria Road that highlighted several economic models in utilising the PV array, the ground source heat pump systems and electric vehicle charging points, potentially achieve a 10% saving against the top energy suppliers in the UK. This in turn will give a financial saving to our residents, which is vitally important at the moment for the energy crisis. Unfortunately, at this time, we weren't able to progress of this due to procurement constraints and availability of suppliers to successfully run a competitive procurement exercise. But we have taken the lessons learnt from this and hope to find a successful route in the foreseeable future. And I just wanted to highlight the benefits of the SOLARISE funding, which has been, so we've unlocked solar capacity on HRA assets. We have the potential to review new economic models and business cases to directly benefit our residents, which is the most important. Enabled the council to produce educational literature and videos to support residents, as well as bridging the skills gap in this country. And it's enhanced housing stock to meet our sustainability targets as well. And I'd like now just to invite you to watch a short video on Victoria Road that has been produced with our partners. If that's okay, if we can just play that one. Thank you very much for listening.
Thanks very much. Brilliant video. I know you were working on that last week, so very good, very well done. And just to say that the Victoria Road pilot built on 3 other pilots in housing that Brighton and Hove has carried out as well, all with the focus on making sure that our residents can actually benefit from using that electricity on site. And Miles, who's sitting at the back there, has had a big hand in doing that. So yes, that's you. Okay, so now we're going to look at 3 pilots which are focusing on historic buildings. And this is one of the biggest technical challenges that we have, to extend the use of renewable energy to historic buildings. And here, the energy efficiency of the building may be poor, the historic buildings, materials and the layout may be difficult to work with, and of course, the visual impacts of the solar installation on the building is of high importance. And of course, how far will the renewable energy help to reduce carbon emissions on site? So 3 of the SOLARISE pilots have taken up that challenge, and we'll hear from them now. And first we have Wendy van den Berger, an environmental specialist from the city of Middelkerk in Belgium. And in a technological first for us here, Wendy is going to join us online and talk about a heritage mill in Middelkerk. So there you are, Wendy. Hello, Wendy.
Hello, Kirsten and everybody. Do you hear me? I suppose you hear me?
We can hear you. Carry on.
Okay. Good afternoon, everyone. I will talk about the project in Middelkerk. It's about a mill. I'm going to talk about our purpose, about the key figures, what did we do with the renewable energy and what will we do with the energy, also about the consumption and which lessons we learned, and the movie, I will keep it till the end. The purpose of it, we made a solar roadmap with the SOLARISE project, but we also want to put PV panels on the site. This is the site of the mill and also a house. It's for cultural events. And with the PV panels, we also have inverters and batteries, and we want to do something with the renewable energy on the site and also around it. But the difficulty about the site is that it's a protected view in the front. It's a protected village view, so we couldn't change anything that should change the view. So we had not so many possibilities to put the solar panels. At least we put the solar panels on a new roof on the back of the site, on the site. It's showed by the red arrow. First, it was an asbestos roof, so we have to remove it. And we only put a new roof on it. We didn't change anything about the stability. We didn't rebuild the walls, but they are really old. And we, the inverters and the batteries are foreseen in the outbuilding, so the building next door on the green arrow. It's the wall between the dark roof and the red roof. So this is how it looks like. It's about 28 PV panels, 2 converters, 2 batteries, 6 kilowatt hours of battery, and the annual production of 8,000 kilowatt hours. Here you see on the right also the inverters and the batteries. And what's underneath the roof, the first picture is under the asbestos roof, but the second picture is under the red roof. what with the renewable energy. So we use it for the house, for the community center. We also wanted to use it for the public lighting, but it's in fact too small scale. The costs are too high for opening the streets, pavement, and they do not outweigh to the benefits. The second possibility is to foresee charging points for cars, but only 1/3 will work on renewable energy. So the rest is from the net, from the distribution. Another thing is the residential neighborhood. It's really residential there. Everyone has his own driveway, so neighbors will load on their driveway and not on the public charge point. So charging point won't be used. Or charging points for electrical vehicle for electric cars, a solution. It's possible, but there is a preference for the local catering that they foresee such charging points, so they can also have the people, and they can drink something while they're charging their bikes, not cars. In the last thing, so we have to go search another option. We now will provide the lifeguard station with electricity in the summer. We also want to provide the public broadcasting system with power in the summer. There we can really use the electricity in the summer. In the next slide, you will see we only have electricity left in the summer. So with a system that we use electricity in the winter, it's not really and it's not longer feasible within the period of the SOLARISE project. The lessons we learned that it's difficult to get permission for installation on historical buildings, and especially the protected village view made it difficult. And charging station for car in a residential area has little added value. I see this is in Dutch, but you can see about the kilowatt hours that the first 1 and 2 years, it's really high. There are also been works. They built the house, the cultural center. They built it new, so they renovated. That's why the electricity was low for this building. And in the next slides, you will see what the installation does. But if you want to compare it to the other years, yeah, you can see it here. And in the year 2020, 2021, you don't see the effect because it's installed in March, and we had just the winter was just passed, and the last period is a period of 4 months, so that's it's not a fully year. The advantage for the environment, we had CO2 production that is not made, about 3,400 kilo, and that's the same as almost planting 101 trees. Here you can see the production of the installation. In green, you see the PV production. Red is the consumption, and blue is the own consumption. That's for the year 21. in total, it's 41% of own consumption. We have to export almost 60%. About the consumption, if you also look at the year 2022, it's not completed yet, but we can now make the first comparison from the months March, April, May, compare it with 2021. You see, April is almost the same. March we can't fully compare because it's only started in March 21, not 1 March, but a few days later. And yeah, May is not completed yet, so we can't see this yet. So now I give the presentation back to you and you will see the video.
Is een Belgische gemeente aan de kust, gelegen in de omgeving van de Stende. De gemeente is reeds voorzien van een 20-tal PV-installaties op verschillende gemeentelijke gebouwen. Middelkerke is partner in het Europese project SOLARISE. SOLARISE is een project waarbij hernieuwbare energie wordt geboost op oude, historische en openbare gebouwen. Op de schuur van de erfgoedmolen, de Groenhagenmolen, liggen 28 PV-panelen. Verder zijn op de site ook 2 omvormers en 2 batterijen van elk 3 kilowatt voorzien. In Leffingen, een deelgemeente van Middelkerke, wordt voldoende hernieuwbare energie geproduceerd om de noden van de site zelf en een deel van de omgeving te dekken. Het molenaarshuis werd gerenoveerd en werd een buurthuis voor kleine culturele evenementen en bijeenkomsten. Dit centrum kan nu gebruik maken van de duurzame energie uit de naastgelegen stal. Niet alle geproduceerde hernieuwbare energie wordt verbruikt, waardoor we op zoek gaan naar andere doeleinden voor deze energie. Bij de start van het project werd vooral gefocust op oplaadpunten voor elektrische voertuigen, fietsen of zelfs de straatverlichting. De aansluiting op het net gebeurde in januari 2021. Daarna startte de monitoring op om de effectiviteit ervan te meten. Dit gebeurde in nauwe samenwerking met KU Leuven. Gemeente Middelkerke bekeek nu de optie om een systeem op te starten met het opladen van batterijen. Daarmee wenst de gemeente de redderspost in de zomer te voorzien van elektriciteit en het omroepsysteem te voorzien van voeding. Het omroepsysteem of de reddersposten zijn niet realiseerbaar meer binnen de tijdsperiode van het SOLARISE-project. Kortom, dankzij het SOLARISE-project werd het voor de gemeente Middelkerke mogelijk om de site van de historische molen te voorzien van zonnepanelen en is het gemeenschapszaaltje zelfvoorzienend. De overtollige energie wordt niet zomaar op het net geprojecteerd, maar naast het eigen verbruik wordt ook een oplossing gezocht in een batterijsysteem voor het omroepsysteem van de reddersposten.
Thank you, Wendy. That was brilliant, and I think a really good illustration of how the thinking has to change during the course of a project. And just to note also that all of those videos will be available on our website after the conference. So now I'd like to invite up to the stage 2 colleagues from the city of Middelburg in the Netherlands. And I remember going to visit Middelburg. It was my first introduction to SOLARISE, and it was such a fantastic place because it's a really beautiful, historic city. So we have Tini Manhout, who is EU Project Management Lead, and Winnie Versol, who is Project Manager. So if you would like to come up to the podium, thank you.
Thank you. Thank you, Kirsten. It's lovely to be back here in Brighton and Hove after 2.5 years of pandemic. So thank you very much for organizing this. I have had the honor to be here often, very often in the past as well for several European projects. So it's great to see you back. So like I said, Middelburg is the capital city of Zeeland. We have 48,000 of inhabitants, and we aim to be energy neutral in 2050. We don't have so ambitious plan like you in Brighton Hope, but 2050 is our aim. And of course, the challenge is that we are a very historical city. We have more than 1,200 monuments in this city. They're all protected. So it's a challenge because of the big regulations we have, regulation safety, but also regulation and visualizations of panels. So we try to show you now three interventions we have done in Middelburg, and which we think, which are of interest of you. So first we go to the Zeeland Archives. It's our original historical center in Zeeland. It stores more than 34 kilometers of private and collections, private collections, also collections of the municipalities, authorities in Zeeland. It is in 3 depots, and it has, it's underground more than 13 meters. So it uses a lot of energy, of course. The Zeeland Archives are also housed in 2 buildings. We have one new building that is made in 2000, but also a very historical building. It's an old palace that is from 1765. So the challenge was here, of course, to make a balance in the 2 buildings and also to find a way how we could put those panels on the roofs. Because we could make a tailor-made installation on the roof, which we had to make because all of the safety rules, we could put on more panels on the roof than foreseen. So we could put 781 panels on the roof. So we have used really the whole roof, and that's also we can now have a production about I think 95,000 kilowatt a year. So that's a lot. And the archive is using the whole, all the energy production for the archives. At the entrance of the archives, where the public is coming in, because we have a lot of visitors, you can find a whole display showing the visitors how many energy we have produced that day, and the costs also which we have saved. The second case I want to show you is our Q-roof system in the Helm. It's also a very old historical building with slates on the roof, and we try to find a solution for that. So we have found a solution with pipes under this, in that system, which is heating then from the sun, and we use that for the boilers, so the heating really the water boilers. And perhaps we can have now a look at the film.
I am responsible for the energy transition of the municipality of Middelburg, a lovely historic town with over 1,200 listed buildings. We are situated near the lovely beaches of the southwest coast of the Netherlands. Our municipality is very progressive when it comes to making listed buildings more sustainable. We are developing a strategic plan to maintain and strengthen the historic city centre and to be energy neutral by 2050. But it's a challenge to find a good balance between authenticity and the implementation of new solar technologies.
We are on top of the City Hall, inside the City Hall of Middelburg, beautiful building. Outside it's about 25 degrees, but it is sunny. So we see that the roof is very hot. Q-roof is a system with aluminium high conductive plates, transport the heat to a hose system, a pipe system. The heat of the slates are in that way transferred to the liquid in the pipe. It puts the heat in a boiler system, and if I check now, the water in the boiler system is 72 degrees Celsius. So it's clear that Q-roof can really help to get the heat from the roof into a boiler so you can have a hot shower with help of the natural sun.
We decided to apply the demo project on a roof facing south. This way, the sun shines on the tiles and the tubes are needed all day. Slates have a higher density than normal tiles, like concrete or clay, so the sun can heat up them more quickly. Since we will monitor how the system works, for an entire year, we will keep track of how quickly a boiler of 150 liters of water can heat up to get a clear picture of the new system's efficiency.
Our company is specialized in renovation of old roofings of buildings such as churches, castles, all kind of monuments in the Netherlands. And we are proud with cooperation with the government of Middelburg, our home city, to make the first time the Q-roof system.
It's the first time we use Q-roof behind slates. And it's nice that Middelburg, with the many monuments there are, and especially with the SOLARISE project, we are able to do this pilot to really measure how much heat can we produce with this system on a beautiful monumental building like the City Hall of Middelburg.
The most beautiful thing about it is that it is under the roof. This is not visible at the outside, such as normally sun collectors. They are visible and you don't see it at all.
Now there appears to be a solution to be able to use solar energy on buildings with slates in an invisible way. Thanks to the Interact 2C's project SOLARISE, we were able to realize this demo project on the roof of our beautiful historic City Hall.
So you have now met our colleague Annette, and I give now the floor to Winnie, who will explain more about the new vertical panels that you have put on our theatre.
Okay, I'm very happy to show you another innovative application of solar panels in Middelburg, in a protected area, which is the energy wall on our city theatre. It's a building from the 60s, but it's located at the edge of the city center, and it's also a protected area. Well, we wanted to put some innovative solar systems here as well. So we started with a sunshine study. It's clear that the entrance of the building is almost perfectly on the south side of the building, so there's a lot of potential for solar. So this was a positive outcome. And here you see the possibilities for the solar panels on the roof. But we wanted something visible, so actually the choice was on vertical solar panel applications. So we were looking for examples, existing examples, to see if they were possible in our case. There's already a lot out there to get inspiration from. All kinds of colors, materials, all kinds of looks, also in the windows, for example. But we chose in the end to put the solar panels next to the entrance on the south facade. Another option would have been the tower, but that was not allowed by our spatial quality committee because of the typical characters. And also the budget was not sufficient. So in order to have something really nice and visible and as a nice demonstration project, we chose to put the solar panels next to the entrance. So 2 times 20 square meter. We found in the end the company SOLARISE. It's a Dutch company who makes solar panels with nice graphic designs. The 40 square meter in total generates 3,200 kilowatt hours, which is about 1 household, and that equals a CO2 reduction of 1,379 kilograms, which is about 69 trees. There are a lot of possibilities in terms of colors and patterns in the end. Together with the Spatial Quality Committee, we chose for some, they were in real life, they look like red stripes. And it's nice at the theater to have some red curtains next to the entrance. So that was basically the idea. So in the end, this pattern from at the right-hand side was chosen. So it's printed in the glass, which is very durable and will stay like this. The implementation was done in October. And yeah, that went all well. And this is the end result. And it's actually funny because people don't even realize that these are solar panels. So that's also, well, a pity, of course, but it's also, it's also, you can see it's possible to have some almost invisible solar panels in a nice way like this. So we hope to inspire other projects by this. Thank you.
Thanks, and that's great. And I think one of the things that really strikes me about that is how you've used real innovation and new technologies on those old buildings to come up with a good solution. So, but yes, we can take some more questions on that later. So now is our last pilot looking at historic buildings, and we will join Ina Klinkers, who is Head of Department, Management and Policy in the city of Zurcel in Belgium. And hello, Ina. Hi. She will be talking about pilot solar on a historic building in Zurcel. So over to you, Ina.
Thank you very much. Hello, everyone. We would like to present to you the pilot project of Zurcel within the SOLARISE project. Zurcel is a rural municipality in the north of Belgium, located in the province of Antwerp with approximately 22,000 inhabitants. Today's presentation brings us to our sub-municipality Halle, where currently vicarage is being renovated and a new village hall is built next to it. The project started in 2015 at a time when our board decided to enter into a public-private partnership for a broader redevelopment of our sub-municipality Halle. Within this vision, the private partner was asked not only to look at the possibilities for merging two locations of our local primary school for the construction of private housing developments with special attention for social housing, but also to revitalize the local village hall. For the upgrade of the existing village hall, our private partner proposed to relocate it and build it centrally in the village center of Halle, next to the vicarage. The ideal match for a SOLARISE project. As will be shown later in the video. The SOLARISE project also brought other interesting benefits to Zurcel. From the other work packages, Zurcel received support in the further development of its climate plan. With the extra resources of Europe, Zurcel also has been able to set up a citizen panel with about 400 inhabitants. They have been questioned several times until 2019. They also has been asked about their opinion about climate, energy, and housing. They especially wanted to learn more about sustainability, biodiversity and saving energy on their houses. The Futura Festival, one of our events within SOLARISE, a climate day for our citizens in 2021, was then focused on these themes. We are also grateful for the other subsidy opportunities that SOLARISE project provided us with. But the biggest output in the project is our new village hall with a renovated vicarage. The vicarage was completed in 1863 and listed in the Flemish Inventory of Architectural Heritage. The vicarage is now equipped with an innovative heating technology that allows Zoorsel to use solar energy without a visual impact. The works started in August 21. The start of the works has been postponed several times due to an active action group of neighbors. But this evening, we are sitting back together with these neighbors to discuss the future user rules from the hall. So I hope that the sun will shine again on this project and that the project can also convince you there in Brighton. Thank you.
Hello everyone, my name is Joke de Beukelaar. I'm project leader of the municipality of Zoorsel. We would like to present to you the pilot project in Zoorsel as part of the Interact 2Cs project SOLARISE.
Zoorsel is a rural municipality in the north of Belgium, located in the province of Antwerp with approximately 22,000 inhabitants. The municipality of Zoorsel consists of three sub-municipalities: Zoorsel, Sint-Antonius and Halle. Today's presentation brings us to Halle, where the vicarage is currently being renovated and a new village hall is built next to the vicarage. The village hall will replace the former St. Maarten Hall, which in turn will be converted into residential housing. The aim is to organize a wide variety of activities in the village hall, from theater performances to baby showers. The location next to the vicarage was carefully chosen by the project team. As the village hall will increase the visibility and use of the vicarage, it can resume its prominent role of the past. The vicarage in the parish of St. Martinus was completed in 1863 and is listed in the Inventory of Architectural Heritage. However, it is not a protected building. The renovation of the vicarage will fully preserve the structure and character of the building while respecting its heritage value. It was quite a challenge to find a good balance between the authenticity of the building and the implementation of new solar energy technologies. This is the new roof of the vicarage. As you can see, it is a slate roof. What you cannot see, however, is that a solar collector is installed underneath. We have used a thermoslate system from Coupa, which has a modular design. Each panel covers approximately 1.5 square meter. It already incorporates the necessary tubes and has a natural slate finish. It is a simple plug-and-play installation. Although at first glance the system seems to allow for quick and easy installation, its integration does require special attention. First of all, the panels must be properly black-filled to create the correct plane and to get a blended look when the roof is finished. This was not the case when they were installed, creating a sort of pit in the roofing and an uneven layer of slates. After removing the slates around the panels, the problem was solved by fixing an extra strip under the thermoslate panels. Particular attention must also be given to tightening the couplings properly. They must be put under pressure before installing the surrounding slates to make sure there are no leaks. The couplings are completely imperceptible once the slates are installed. The solar collector on the roof of the vicarage is connected to this buffer tank in the technical room of the village hall. The solar energy from the vicarage is used only for the new village hall. The vicarage is heated by its own existing boiler, but a future connection to the solar connector is still possible. In addition to direct solar heating, the buffer tank is also fed by 2 heat pumps. These pumps are at the core of the innovative heating technology of the new village hall. The traditional heat pump is already a well-established technology. It extracts free heat from a low-temperature environmental source, such as outside air, soil, water, etc., and transforms it to useful heat energy at a higher temperature using additional electrical energy. To minimize energy consumption, the addition of electrical energy must be reduced to a minimum. And herein lies the innovation of this heating technology. It combines 5 freely available natural energy sources and allows the heat pump to use a source with the highest possible temperature. These sources are sun, air, soil, water, and ice. The solar air energy is absorbed by a solar air absorber, which differs from a solar collector. A solar collector heats small quantities of water to a temperature of 90 degrees. Solar air absorbers function in a different way. They produce large quantities of warm water with a temperature from 0 to 10 degrees. If the building does not require heating, the absorbed heat is stored in an underground ice buffer for later use. The ice buffers are 6 tanks of 10,000 liters installed in the ground of the vicarage garden. They have a total capacity of 60 cube. A particular concern here was a large excavation area due to the considerable size of the buffers. The contents of the ice buffers will vary from completely frozen water to water of 10 degrees. But what is ice heating exactly? Heat is required to melt ice. Conversely, the same amount of heat is released when water freezes. This energy is called the heat of crystallization. It indicates the amount of energy exchanged with its surroundings when a substance undergoes a phase change. It takes the same amount of energy to melt 1 kilogram of ice as to heat 1 kilogram of water from 0 to 80 degrees. By placing a heat exchanger from the heat pump in the ice buffer, the energy can be sucked out of the ice or water. The cycle of the seasons will determine the use of the regenerative sources. In summer, excess heat from the absorbers is stored in the water of the ice buffer. There is hardly any heat loss in the ice buffer because the water gets no warmer than 10 degrees and the ice buffer is installed underground, with a more or less constant salt temperature between 8 and 10 degrees. In this way, the earth also contributes to the system. At the start of the heating season, the control system will determine the best heat source and create an interaction between the ice buffer and the solar air absorbers. It will use the temperature in the best possible way for the building. After a few weeks of heating and an increasing use of the ice buffer, the water temperature drops from 10 degrees to freezing point. When the water actually starts to freeze, a sufficiently large amount of heat is released to heat the building throughout the whole season. At the end of the winter, the ice buffer is almost completely frozen. In spring, the process is reversed. No heating is needed in the building for some time. The heat from the solar air absorber is used to regenerate the ice buffer. When temperatures are higher, the building needs passive cooling. The ice water is used to cool the building. The heat disappears from the building and is stored in the ice buffer, recharging it for the next heating season. The control system is an indispensable part of this process, but it takes up quite a bit of space. As you can see, the control boxes to which the ice buffer tanks and solar absorbers are coupled. As this system is still new and unfamiliar, it required a great deal of consultation and coordination between the suppliers and subcontractors, especially regarding its integration with the building management system. As you can see, the construction of our village hall is almost finished. The works will be completed by the beginning of July. From September onwards, the hall will be in use and we will start monitoring the entire system. Thanks to the Interact 2Cs project SOLARISE, we were able to equip this building with an innovative heating technology that allows us to use solar energy without a visual impact while preserving its heritage value.
So, the village hall and the renovated vicarage will be used soon. Everybody is welcome to visit them. Thank you.
Thank you. Thanks, Ina. That's, I mean, really just so much innovation going on here. It's great. So now we have a few minutes for some questions. So I would like to invite our speakers so Winnie, Tini, Joe and Dan to come up to the stage again. And also, if we can, to have Ina and Wendy on the screen. If we can manage that, that would be brilliant. But yeah, I mean, I think we're just getting a sense of all the innovation and the level of effort that's going in to provide solutions for these different buildings. So I can see that we've got a few questions coming in from our remote viewers, so I'll take those in a minute. And also think about your own questions in the audience here. But one thing I'd like to ask is, Tina, you mentioned that in your that you show the monitoring of all the solar power that's been generated in your public building, and that's something that the public can see. Do you think that this helps to engage the public in thinking about renewable energy?
Oh yes, indeed. It helps very much because everyone who entered the Zeeland Archives sees when the entrance the big display, and it's also translated in money. So that's interesting for people that they see immediately, yes, not only the energy, but also what it means in your pocket.
I can see some technical questions coming up. Could we just scroll down slightly so I can see the full question there from Adrian Turk? Flexi pipes are indicated on the panels. What is the lifespan of those pipes, and is there a way of inspecting them? Who was using flexi pipes? Flexi pipes. No, nobody coming up. Okay, think about that one and we'll come back to it. Another technical question. Why have all the projects used solar edge inverters? There are other solutions that control PV systems at the individual panel level. And that is from Tom Broughton.
This was, as I said, just selected really for, there are other options out there, but it was just at the time, this is what was designed into the system, this is what was procured. So there was no specific reason, there are other options out there, obviously, yes. But yeah, we just, this was a case of just designing a system that we could look at to optimise as much energy as possible, as well as using a system that everybody could use. There's no specific reason as to why we're just using these systems.
Is it a question of those are the sort of most easily available?
Yes.
Yeah, okay. Can we, is anybody in the audience who would like to put a question to her? Yes, we got Raleigh over at the back there. I think you've got the mic.
Yes, thank you very much. I'm very interested in you as a group, and my question is about how did you work together, and whether there were opportunities for the different local authorities to learn from each other. So did you implement something from one of the places to a pilot in another place? Thank you.
Not really what the interventions. For example, before the pandemic, yes, we had a big meeting in the Netherlands, and it was also about what the rules, what can we expect when we do these interventions in historical surroundings? Because you're not only dealing with, for example, your panels, but there's coming so much things around, like, for example, the safety. If you put panels, special panels in historical surrounding, you must have a special installation before you can put the panels on the roof. what does it mention for your insurance as well? What does it mention for your the fire brigade? So there's coming so many things you have to take into account when you put on solar panels in a historical surrounding. It's not evident. It's not only finding the balance between aesthetical things and your historical city, but there are coming so many other aspects which you have to take into account when you start with a project. I think that was also that we have learned a lot of each other. What does it mean when you start a project like this in your city?
I think from Brighton and Hove's perspective, we've got 94 grade 1 and grade 2 listed buildings in the city. And I know within our city plan, we have pledges around that in terms of rolling out our sustainability technologies. So we'll be looking really closely at the Netherlands and those case studies to see whether we can apply the same technologies to those listed buildings in the city, because that's the real opportunity here. You've seen some of the Regency architecture. It basically, and the Royal Pavilion as well, could we integrate those sort of technologies to achieve our 2030 target? And I think we've really got to push for that. And I think our heritage team will be delighted to see the results of your studies in order to inform that thinking.
Thank you. And Karen, you've got the microphone there.
Kirsten. A question for Joe and Stan. You mentioned that you used some of the funding to bridge the skills gap. And I'm just wondering if you could give us a little bit more information about, A, what the skills gaps that you experienced were and how you used that money to fill them.
So we used some of the funding to produce some really good kind of time-lapse videos and drone footage. So not just of the solar PV, but the whole scheme itself, which is fantastic. We know we've got some skills gaps where there's emerging technologies coming through. This particular scheme has got, as I said, it's the most heavy sustainable project we've ever done. So we've got a light steel frame system, we've got ground source heat pumps, which we've never done before. We've got solar photovoltaics, obviously on the roof. As I said, we're trying to do a private energy system. So there's so much involved, but it's the skill to bridge the training gap, I suppose, across the whole of the council as well as our partners, and showing how we installed it, not just this is our set of design requirements, this is what we want to do, but this is how we did it. But showing obviously not just technical officers, but obviously also our housing colleagues and everybody else, and also residents, which is the foremost is what these systems we're providing. So it's just it's so important to have these kind of videos and literature.
And just to sort of emphasise as well, with our contractors, Morgan Sindel, who are very innovative in terms of sustainability, they've developed Carbonica, which is a whole life carbon assessment tool. And this project has been the pilot project for the Carbonica tool. So we've got embodied carbon and operational energy being measured as a result of this, the construction process, but then in use as well. And we won't really know the benefits coming out of that until a few years after its completion. But at least with that tool, we've got the opportunity to really assess what the energy take-up is. And also, when we hopefully do roll out a private network, we'll be looking at an average week of a tenant to see what their usage is and be able to evaluate that, maybe with a view to installing battery technology that would then enable that usage to be optimised. But it's like you were saying, I think we need to read some of the case studies here, because there's obviously a balance to be struck between that battery technology and just going straight to tenants. So, because it requires usage, and I've learnt something today that I didn't know about before, so thank you for that. But those case studies are going to be really good. The other thing quickly to say is we have got a show flat that will be ready in around June of this year, which will help to demonstrate to tenants some of the technology, prospective tenants, when they come to see the show flat. but also it will be used by our M&E colleagues to familiarise themselves with the technology, maybe also to teach them how to repair and maintain these systems. So thanks to Morgan Sindel for organising that.
Thank you. And yeah, we have a question there from John.
Thank you. Question for Winnie. With the facade panels, the decorative coating and the angle they're mounted at, does that impact their output much?
Yeah, I think compared to normal solar panels on the roof, it's a reduction of about 30%, if I'm correct. But I remember that the website of the company also is very clear about the production of each type of pattern. So it also depends on the pattern how the production, the efficiency is reduced. Yeah, it's not as efficient as a normal solar panel, that's clear.
Yeah, all these trade-offs that you have to consider in a project. Yeah. Well, thank you very much. I can see one more question down there from Julia.
Thank you. Yes, I have a question actually for the project of Zorsel. Yes, so you said that there was some resistance from the local communities there, and yeah, you said, oh, finally, now here we are. Can you just expand a little bit more what kind of negotiation happened there, and how did you manage to finalize your project then? Thanks.
Thank you for your question. The resistance of the neighbors was in the beginning especially focused on the village hall next to their houses. At the moment, the village hall is 2 blocks further. In the beginning, there was no space for recognition. We tried, but they only see the problems, the noise that the new village hall will bring with it. So we have to run through a whole juridical debate. But at the end, the judge gave us a go for the works. And it's at that moment that we reactivated with the neighbors again. And that's at that moment that we feel that there was again some space to talk with them. And we tried to find some issues that were still discussable, such as the user rights, such as the maximum capacity of the hall. There could be place for 400 people, but we blocked it on 119 persons, the same as the former village hall. We also put a limit on the noise level of the village hall. And last Sunday, the works were open for public. We gave them a lot of information also about the SOLARISE project, and we felt for the first time that most of the habitats, also a few neighbors, are seeing the sun now. But we learned that we must give more information before the start of the works, more room to give their opinions before we close all the contracts, because now we have to search for openings after all the juridical debate. So that's the tip of my Is it clear?
Thanks, Ina. So I've got one more question from our online viewers, which is about the Victoria Road development. How have individual flats at Victoria Road been connected to the PV system? Perhaps one for you, Dan.
Yeah, that's right. So as I said earlier, we're trying to create, or looking at trying to create a private network as such. So the actual photovoltaics aren't connected through to the individual energy or electrical points of individual apartments. It will go into the communal system. But as I said, what we're looking to do is, we've seen through SOLARISE, is look at to maximise what we can do on the whole scheme rather than the individual apartment. To obviously generate hopefully a saving on energy bills with combined of the PV, the ground source, electric vehicle charging combined, rather than using the PV individually for one apartment as such. So that hopefully that's how the residents will benefit from this system, rather than, as I said, individually into the apartments.
Thanks. And I know you've got a very detailed information that about this, if anybody wants to ask questions about that later. But I think we've now come to the end of our time this morning, and I would like to thank all of our speakers this morning very much, because you've actually, really done us proud on this. So thank you. And thanks also to our technical team who've done such a great job so far. We're expecting even greater things this afternoon. So now is time for lunch. We'll reconvene at 2:00. And for our remote viewers, that's on Central European time, that is 3:00. So anyone following us in France, Belgium and the Netherlands. And this afternoon, we have we have a wider view. We're looking to the future. What is the future for solar energy from the perspectives of all the different sectors who are represented here today. So thanks everybody very much for your participation, and it's go out and enjoy some lunch and some networking with your colleagues. We'll see you later. Thank you.